Okay, so anyone else out there just feel like sometimes you're just drowning in information.
Oh, yeah, absolutely. I know what you mean.
Like emails, articles, social media, it's like a fire hose sometimes. And it turns out that even the most like advanced AI models are actually kind of dealing with the same problem. They
Interesting.
have a hard time dealing with this information overload too,
Makes sense, I guess.
which is why I'm actually super excited about this deep dive today. We're looking at this article about this new approach called mixtures of in-context learners.
Wow, that's a mouthful.
Yeah, it is, isn't it?
Yeah.
So we'll just call it MoICL for short. But it's basically like giving AI a memory upgrade,
Interesting.
helping it learn even when it has a limited memory.
Okay, I'm intrigued.
So, I know in-context learning, that's like a super jargony term.
Yeah.
It sounds really complicated, but it's actually really intuitive. So, I mean, maybe you can give us the quick and dirty explanation. Like, how does in-context learning actually work? Can you give us like a real-world example?
Sure. So let's think about how we learn as humans. So say you are trying to figure out what a cat is.
Okay.
We don't really need some big textbook definition. We just see a lot of cats,
Sure.
right? Like a bunch of fluffy ones, the sleek ones, the grumpy ones.
Exactly.
And our brain figures it out.
Yeah.
Our brain figures out the patterns, and that's how we learn what a cat is.
Yeah.
And in context, learning for AI is similar. It basically sees examples and it learns from that.
Right. So the more data it sees, the better it gets at a particular task.
Exactly.
Okay. So how does the limited memory issue come into play here? I mean, is this kind of like when we're studying all day and our brains just get full?
That's a great way to think about it.
Okay.
Yeah. So these models, they have what's called a context window.
Okay.
And that's kind of like their workspace.
Okay.
But like our brains, it's limited. There's only so much they can hold in there. So if that context window is too small, then it's hard for the AI to really process all of that information.
So it's like juggling. You can only juggle so many things at once before you drop everything.
Yeah, exactly.
Okay. And that's where I think MoICL comes in. It's a
Yeah.
super clever solution to maximize, that limited memory. Tell me more about that.
Yeah. So imagine instead of having like one big brain trying to do everything, you've got this team of specialists
Okay.
and they're all experts in their own little areas and they can each focus on one part of a task. And that's kind of what MoICL is doing.
Right. So dividing up the labor a little bit.
Exactly.
Okay.
Right.
But I'm still a little fuzzy on how it works. Like, how does the AI know which specialist to talk to for every single piece of information that it's seeing? It seems like that could get really disorganized really quickly.
Right. That's where the gating mechanism comes in. So basically, there's this mechanism and it looks at the data that's coming in and it's looking for clues, like keywords or patterns. And then based on those clues, it sends that data to the right learner.
So it's almost like a traffic cop directing traffic,
Exactly.
making sure everything's flowing smoothly.
Right.
Okay, that makes a lot of sense. But is there proof that this actually works? Like, what are we seeing in the real world? Are we seeing MoICL actually make a difference?
It's really impressive, actually.
Okay.
So the results are really good. So this article talks about how MoICL has actually really improved performance in all kinds of different classification tasks, especially when that context window is really limited.
Yeah.
So you could think of like customer service requests, and AI could look at those and try to figure out how to respond to them.
Okay.
And with MoICL, it can handle a lot more requests, even if it doesn't have a ton of memory to work with.
So what kind of difference are we talking about? Like, how much better is it doing?
Like we're talking like a 20% increase in requests that it can successfully resolve.
Wow, 20%. That's huge.
Yeah.
And I mean, that's a win for AI, obviously, but it's also a win for all of us who are dealing with this information overload. I mean, it's almost like having your own personal assistant who can just like filter and prioritize all that data that's coming at you.
That's a great way to think about it.
So I'm kind of curious about something else. You mentioned earlier that these models have a context window, and that's like their workspace.
Right.
But you also said that MoICL helps them learn even when that context window is really limited.
Right.
So I'm wondering, like, does MoICL actually make the context window bigger, or is it doing something else?
It's not actually making the context window bigger. It's more about like using the space that it has in a smarter way.
Okay, so it's like efficiency expert.
Yeah.
Like it's coming in and saying, okay, here's how you can organize your workspace and make the most of what you've got.
Exactly.
Okay, that's fascinating. And the article also talked about how MoICL is really good at dealing with unexpected information. Like it's flexible and adaptable, which, I mean,
Yeah.
are those things that we want AI to be able to do, right?
Yeah, absolutely. I mean, if you think about AI that's supposed to drive cars, You don't want it to just shut down when it encounters something new.
Yeah, like snow.
Exactly, like snow or a detour or something like that.
Right.
So MoICL lets AI be more flexible so it can adapt to these situations and learn from them really quickly.
It's almost like it's learning on the fly, which, I mean, that's amazing.
Yeah, it's really
Yeah,
cool.
it's like it's learning how to learn. So the article also mentioned this other really cool benefit of MoICL. It said that it actually helps find this balance between model capacity and memory constraints.
Hmm.
Can you explain what that means and why that's important?
Sure. So, AI models, they are really big. They have a lot of parts,
Right.
but they also need to be able to store a lot of information to work well. And that's where memory constraints come in. It's like trying to fit, all the information in the entire world into a tiny little box.
It's not going to work.
Right. It's just not possible. And so this is a big challenge in AI.
Yeah.
And MoICL, it actually helps us work around this problem.
Yeah.
It doesn't make the box bigger. It's more about finding a smarter way to use the space inside the box that you already have.
That makes sense. So this has been a really interesting deep dive.
It has.
We've talked about in-context learning and MoICL and all these other really fascinating things. But as we're wrapping up here, I'm wondering if there are any other big takeaways from the article that you think our listeners should really hang on to.
Sure. I think one of the most important takeaways is just how much potential MoICL has. It can
Yeah.
help AI learn more efficiently and deal with limited memory. And that's a big deal because it means we can start using AI for even more things.
Yeah, you're right. I mean, that's really exciting to think about. And it also makes you think about our own learning, right? I mean, if AI can figure out how to learn so efficiently with limited memory, shouldn't we be able to do that too?
That's a great point. I mean, maybe there are some things that we can learn from how these AI models are learning and apply those things to our own lives.
Right. Like, how can we get better at filtering and prioritizing all of the information that's coming at us every single day?
Exactly.
Food for thought, for sure.
Yeah, definitely.
Well, this has been a great deep dive. Thanks for joining me.
Thanks for having me. This was fun.
I'm already looking forward to our next one. It seems like every time we do one of these, there's something new and exciting to learn about AI. It's such a rapidly evolving field, and who knows what amazing things we'll discover next.
I can't wait.
Me neither. All right, that's all for today. Until next time.
See ya.